All right, so this is what we've been working up to. For the last lesson in Unit 6, we're going to get full stoichiometry problems. All right, so far we've kind of done bits and pieces, so we got to combine everything together to get you through a true stoichiometry problem. So an example of a true and just full multi-step stoichiometry problem is something like one of these. If you have 12 grams of aluminum, how many moles of oxygen do you need? Or if you have 6 liters of oxygen, how many grams of aluminum will be made? All right? So you might be starting with grams or volume or ending in grams or volume. There's also the options where you end in moles. Okay? So to get there, you're going to combine mole island plus molar ratio. And what that looks like is this. This is a picture you want to grab a copy of. All right? Have this handy so that you aren't trying to remember all of these little details. Just to understand how to use this picture. All right? Your problem is going to give you a known substance. All right? So this comes from the problem. It's the given number. All right? The 12 moles, the 5 grams, the 6 liters. All right? Whatever value you're given how much you actually have to begin with. All right? Your unknown is the question from your problem. It's the how many or how much. All right? It's one of those, it's an actual question in your problem. All right? And then, if the problem gives you something in mass, then you start here. If the problem gives you something in moles, then maybe you would start here. All right? Or if it gives you something it gives you a volume, you might start here. But then you just follow through the guide till you get to the point where you answer whatever the question is asking you about. So let's do some examples. So this first one, and actually I'm going to switch this to what it said on the first slide. We're going to find moles. So I'm going to show you how this works if you don't quite finish the diagram, and when you do. So our starting point is going to be 12 grams of aluminum, because that's what we're given. So we're going to start here. All right? Which means we need to divide by our molar mass. All right? If you don't remember, you're going to have to look that up on a periodic table. All right? So you've got 12 grams of aluminum. And I'm going to divide that by, rounds to 27 grams per mole. Which is going to give me, let's see what that is, 12 divided by 27, 0.44 moles of aluminum. All right, so now I'm here, which means I'm at the molar ratio step. So I'm going to set up my parentheses. I'm going to put moles of aluminum in the bottom because I need to cancel that out. The question is asking me about oxygen, so that's what's going to go in top. All right, and then my numbers from the molar ratio, little clue on here, that's coming from your balanced equation. So there's a 4 in front of aluminum, and there is a 3 in front of oxygen. So that's going to be 0.44 times 3 divided by 4. Moles of aluminum cancel out. So that gives me times 3 divided by 4. 0.33 moles of oxygen. And since the question is asking me in moles, I'm done. All I had to do was get here. All right? If the question had asked me for mass or something like that, then there'd be one more step to this, which I'll show you on the next slide. So for example, you have 6 liters of oxygen. How many grams of aluminum oxide do you have? All right, so liters of oxygen is where I'm starting. And grams of aluminum oxide is where I'm ending. So I'm starting here and I am ending here. All right, my known is O2. My unknown is Al2O3. So, first step is dividing by 22.4. So I've got 6 liters divided by 22.4 liters, which is going to be 6 divided by 22.4, 0.27 moles of oxygen. All right. My next step is going to be my molar ratio. All right. So moles of oxygen are going to go on the bottom because that's what I need to cancel out. Moles of Al2O3 are going to go on top because that's where I need to go. All right. Let's see. Oxygen has a 3 in front in the reaction. Al2O3 has a 2 in front. All right. So that's going to be 0.27 times 2 divided by 3. Which gives me 0.18. And my units, moles canceled. Moles of oxygen canceled. So my units are going to be what's left. That's the Al2O3. All right. So now I have one last step to get to my end goal here. Let's use green for that. I've got to multiply by the molar mass of the Al2O3. So let's figure out that molar mass. All right, aluminum is 27, so I'm going to have that twice. Oxygen is 16. So 27 plus 27 plus 16 plus 16 plus 16 is 102 grams per mole. All right. And I'm supposed to multiply by that. So I'm going to take that, multiply by 102. And I get 18.36 grams of aluminum oxide. All right. So that's how these guys work. I've got some more samples just so that you can see more. I definitely suggest on the future ones that you pause the video, try it yourself first, and see if you get it right. All right. So here we have, if you have 71.9 grams of zinc to react with excess hydrochloric acid, all right, reminder, when you see that word excess, that means you have more than enough. How many liters of H2 gas will be produced? So what's our starting point here? Because we have excess hydrochloric acid, our starting point is the zinc. All right, our ending point is the liters of hydrochloric gas. Hydrogen gas. All right, so we're starting at mass and we're going to volume. All right, so our first step is to take that 79.1 grams of zinc and divide by the molar mass of zinc, which is, looking this up on a periodic table, 65. And just round those to whole numbers. So 79.1 divided by 65, it's 1.22 moles of zinc. All right, so first step done. Next step is molar ratio. So I'm going to put moles of zinc on the bottom so I can cancel it out. I need to get to hydrogen, so it's going to be moles of hydrogen on top. All right, based on my balanced reaction, zinc is 1, hydrogen is 1. All right, that's an easy calculation for me. That means I'm going to have 1.22 moles of H2. All right, last step is I need to take this 1.22 moles of H2, multiply by 22.4 to figure out liters. And that's going to be 27.26 liters of H2. And there's your final answer. So again, I recommend pausing, trying this one on your own, see if you can get it right. So our starting point, we know we have 60 grams of oxygen, and we want to know how many grams of aluminum. All right, so our known is O2, our unknown is aluminum. We are starting in mass and ending in mass. So, first things first, I need to do 60 grams of oxygen, divide it by 32 grams per mole, which is 60 divided by 32, I'm just going to keep all 5. All right, I just kept all the decimals on that one. Next step is your molar ratio. All right, moles of oxygen goes in the bottom because that's what I want to cancel out. Moles of aluminum goes on top because that's where I need to go. I've got 3 in front of oxygen, 4 in front of aluminum. So that's going to be 1.875 times 4 divided by 3, which gives me 2.5. And my units are going to be what I didn't cancel out, moles of aluminum. All right, but I'm not done. I still need to get this to mass. So now I need to multiply by the molar mass. All right, so that's how I'm going to get to this last part. The molar mass of aluminum is 27, which means I'm going to make 67.5 grams of aluminum. And there's your final answer. So if you take it step by step, take your time with these. They aren't that difficult. If you're going to try to rush it through and do it in your head, mistakes are going to happen. But if this isn't making sense, please, I'm here. I want to help.